Good morning, good afternoon, wherever you may be in the day. Thank you for choosing to make chemistry part of your day. Okay, so today, this should be pretty short. We're going to take a look at, given a metal and given a nonmetal, can we predict the empirical formula of the compound that comes? So let me set the stage. Let me do a couple reminders. Empirical formula is the lowest ratio of atoms between elements in a compound. This is primarily for ionic compounds. And I know an ionic compound when I see one because it starts with a metal. So you have metals and nonmetals combined. And continuing to set the stage, metals are on the left-hand side of the periodic table, nonmetals on the right-hand side of the periodic table. And we're just going to look at the main group families for this. But before we can combine them, we need to know their individual properties. So, back to our friend, the periodic table. And once again, artistically drawn by yours truly. If you can count, you can do this. It's awesome. Even the Muppet can do it. Alright, so first family is +1. Second family is +2. We get into the transition metals, and I want you to be like, there be dragons on the maps. Run away, killer rabbit, killer rabbit. So get out of that section. We're gonna skip that for now. So looking at the main group, 1, 2, 3, 4. Then we just go down. -3, -2, -1, 0. So that's all we're doing. 1, 2, 3, 4, -3, -2, -1, 0, and that's everybody in the family. A quick word though. Remember the staircase here? Everything above the staircase is a nonmetal, tends to be negative. So for arsenic, we might assume -3. Everything below the staircase tends to be a metal, tends to be positive. So in the case of antimony, that might form a positive charge. Now whether it's +5, +3, +1, that's a discussion for a higher level class. But I do want to point out, so when we're talking about these kind of negative charges, it's more towards the top. It's really above the staircase that we're looking for all of these. That's what I want to point out. So it's above the staircase. Okay, 1, 2, 3, 4, -3, -2, -1, 0. All right, so let's use this information we now have. Predict the empirical formula combined by combining the following elements. And a quick note. If it's not an ionic compound, you should note such. I'll just put an NA here for not applicable for the question. Seems the easiest way of handling it. All right, so let's take a simple example. We're going to combine magnesium and iodine. Iodine. We haven't talked about naming yet. Magnesium and iodine. What do we expect again? Well, first thing we have to do is translate this into symbols. So magnesium we've memorized is Mg. Iodine we have memorized is I. Then we go to the periodic table and we see that this is in family 2. And this is in family 17. And then we do the counting thing. So that's 1, 2 in, so that's going to have a charge of 2+. We write the number, then the charge. And then if we look, this is 1 from the end. 18 is the end of the periodic table, so we count out, and that's going to be -1. So the 1's implied, so you just put a negative there. Now, if we were to put magnesium with iodine together, those charges would not balance. 2's do not balance out 1's. If you think they do, I got this wonderful Ponzi scheme for you. Okay, so a lot of books will just tell you the easiest thing to do is take the charges and transfer them down. So this becomes Mg with an implied 1 and I with a 2. So you might write Mg1, I2, but we don't want to put the 1 in there. We want to look like a chemist because who wouldn't? Chemists are cool. If you don't believe me, look at Professor Snape in Harry Potter. Okay, so Mgi2, and we've answered the question. There's a couple things we need to do here. Double check this is the lowest ratio, 1 to 2. That can't be simplified, so that's good. And that's really it. We've answered the question. Make sure we have a metal and a non-metal, and we have that all correct. If you want to see what this looks like conceptually, you could always try to put one of each together and see if it's balanced. Well, that doesn't work. So we have more positive, so add another negative. Now see if it's balanced. +2, -2, that balances, and you can see we had to use one of the positives and 2 of the negatives. And that's what we're seeing represented here. So that kind of building up picture, if that helps you conceptually understand what's going on, you can always do that and it'll work. Whatever you have less of, just keep adding more until you get the right ratio. Okay, so same idea here, carbon and sulfur. So if I go to carbon, it's in family 14. And sulfur is in family 16. Oh, and this is S. And this is C. And they're both above the staircase on the right, so they're both nonmetals, so that's good. And we look at carbon's family, and it's 1, 2, 3, 4 over, so that's going to be a 4 plus commonly. Sulfur is going to be a 2 minus commonly, so we can certainly put those together. And we can do the crossing down thing if you'd like. And if we do that, we get C2S4, which although is a correct ratio, it is not an empirical formula. It's not the lowest ratio possible. The lowest ratio would be CS2. And that would be our correct answer. So when you do the crossing down, I know you'll get where it's kind of automatic, but just make sure that you do check to see if you need to simplify. And if we were doing the same thing over here that we did before, you'd have a plus 4, and a minus 2, and that clearly doesn't match. So we need more negatives. Our units are 2, so now we put 4 and 4, and we see once again we end up that 1 to 2 ratio. A couple more examples, and we'll call it a day. Iron and nitrogen. Oh, that's not what I meant to do. That's okay. Let's not do iron and nitrogen. Let's do iron and copper. I wanted to do one with 2 nonmetals, but that's okay. We'll do one with 2 metals. So if we look, this is going to be a metal, and this is going to be a metal. And yes, you can combine copper and iron and make an alloy, but you're not going to make an ionic compound. So this would be an example that doesn't really work for what we're talking about. Another example of what wouldn't work would be hydrogen and neon. Hydrogen is a nonmetal. Neon is a noble gas. So noble gases are out. Nonmetals need to be reacting with other metals. So this would definitely be one that's out. And if we had aluminum and nitrogen, this is another one we can do. So another example. So aluminum we have to know is Al. Nitrogen we have to know is N. Then we find it. Aluminum's in family 13, which has a positive 3. And nitrogen is in family 15. If we count over, it's 1, 2, 3 over from the N, so it's 3 minus. You might notice the charges are equal and just say, hey, I'm done. A-L-N, boom. Pat yourself on the back. Give yourself a thumbs up. Fist bump, octopus, squid, jellyfish, whatever you like, whatever makes you feel good. Or you could be, man, I just cross these down. I cross them down, I cross them down, I cross them down, which is good. You got it. You're automated. Al3N3, but just make sure, is that a lowest ratio as an empirical formula? No, I can simplify that. ALN, and we are done. As always, thank you for your time, and have a wonderful